Everybody, welcome back. Today we're on pages 14 and 15 in your packet, lesson 7-4. We've learned a lot about quadratic functions and their graphs, the parabolas, and all the different parts. Now we're going to dig a little bit deeper. What we've been working with is standard form. So you have y equals ax squared plus bx plus c, where the a, b, and c are all numbers. And you can tell whether it's going to open up based on whether this is positive in the y-intercept. Well, now we're going to look at a different form, and this is called vertex form. And the reason that they call it vertex form is because you can easily find the vertex by looking at it. Now, keep in mind with all of these, you can always put it into y equals in your calculator and find these things as well. All right, so if you don't remember these tricks, don't just guess. Use your graphing calculator. Now, just like before, if the number in front of x squared is positive, it's going to open up, concave up. If it's negative, it's going to open down. But this is no longer your y-intercept. All right, the number in the parentheses with x is the x value of your vertex. You just have to remember to change the sign, and then this is the y value in your vertex. So my vertex of this would be, since it's negative h, it would be positive h, and then leave the sign there. So those will obviously be numbers. So let's do some practice with this. So looking at this, it's in vertex form. Whoops. So what that means is whatever's in your parentheses with x, change its sign. So the vertex will be positive 2, and then the y value is going to stay negative 7. But again, do you have to memorize that? No. I mean, it does make things easier. I will say that. But if you go to y equals and type this in, parentheses, x minus 2, close parentheses, squared minus 7, and take a look at the graph, hit second graph to look at your table, scroll down to the numbers we can actually plot. When I say what's the vertex, the turning point, you can see it right there, 2, negative 7. But the shortcut is the number in the parentheses with x is change its sign, that's the x value, and the number outside is the y value. All right, so we're going to graph that function. We have our points there. You can make a table pretty easily. So I'm just going to copy these points down. And I know I can't write very neat using Cami, so I get it. I prefer paper, but we'll go with this. So I can't graph 9, so I'm going to do negative 1, 2 to 5, 2. 1, negative 6, 2, negative 7, and that's your vertex. So now it goes to 3, negative 6, 4, negative 3, and 5, 2. Okay, and again, if you leave this open, you can make sure that you're graphing it the same way they are. But right here, remember, everything has a match except for that vertex. 2, negative 7 is going to be right here. That's your turning point right here on your graph. All right, so let's graph those. Negative 1, 2, so we're going to go back 1, up 2. 0, negative 3. Now I want to point out, before when it was in standard form, this was the y-intercept, but this is not standard form. This is vertex form, so that's not your y-intercept. 1, negative 6. 2, negative 7 we already have. That's your vertex. 3, negative 6. 4, negative 3. And 5, 2. All right, and just like anything else, we're going to want to carefully connect those dots and make that nice smooth curve. Remember, what's that called? Parabola. Arrows, and then off to the side I'm going to label it. we have to write the whole thing because it didn't give it a name. If it was f of x equals or something like that, you could just label it like that. All right, now it says graph the function y equals x squared on the same set of axes, and we want to compare those. So I'm going to go back here. Y equals, you can leave that in there and put it down here. You'd see two graphs. All right, so y equals x squared is going to be that red graph. If you go to the table that way, you're looking at the y values here. So you can see I'm going to go up to where these are repeating. Again, I can't graph a 9 on there, so I'm going to do -2, 4 to 3, 9. Or excuse me, -2, 4 to 2, 4. And this is just your basic quadratic function. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1, 1, 2, 4. All right, and again, this is what your graph should look like, this red one. I'm going to switch up my colors as well. So there's my vertex at 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. And we may make, when we make that U shape, that's what we have. Y equals x squared. All right. Now it says, how do they relate to each other? Well, if you look at your vertex, it's right there. Each of these is 1 away. All right, these are all spaced out the same. What happens is your graph shifts. All right, so this is the standard equation right here. If I'm moving to this one, I'm going to the right 2 and down 7. So when you go from y equals x squared, you're going to go to the right 2 and down 7. And if you notice, every single point does that. If I want to go from this point to this point, I go to the right 2, down 7. If I want to go from here to the matching point, right 2, down 7. All right, that all comes from this equation. All right, again, this is vertex form. You can find the vertex, but this is called a horizontal shift. It tells you that it goes to the right or left. You just remember to change the sign. You would think seeing -2 would go to the left, but it actually is backwards. It goes to the right and then down 7. But again, you can always, always, always use your calculator and compare those like we did here. All right, so that brings us to transformations of quadratic functions. It's just what we talked about. So again, if A is positive, it's going to open up. If it's negative, it's going to open down. The bigger A is, the skinnier your graph is going to get, the steeper. All right. This is called your vertical shift. All right. So if it's positive, it goes up. Wow. Gotta love Cami. If it's negative, it goes down. With the horizontal shift, though, remember things are backwards. If it's positive, you're going to go to the left. If it's negative, you're going to go to the right. All right, so what's the vertex of this? It's going to be +8, -10. Again, change the sign, keep the sign. If you didn't know, put it into your calculator. Compared to its parent function, describe what transformation occurred. Again, if you want to, if you're not sure, leave the parent function in there. I'm just going to clear this one out. So this is called, the parent function, y equals x squared. Every single one has an x squared, and then it's altered from there. So now if I type this one in, we can compare what happens to it. I mean, the shortcut is to memorize these things, but you can always look at the graph. So let's take a look at the graph. Oop, it was shifted really far down, so that's why we're not seeing it. Hold on. and it's flipped. So if I go to zoom out, you would see some things. All right, you can see that it got more narrow. It flipped upside down because it's negative, and it was shifted. All right, so let's talk about those shifts based on the equation, though. So what transformations occurred? Well, the -3 means it opens down, and it got more narrow. And then the -8 in parentheses means that it shifted to the right 8, and the -10 means it went down 10. Okay? That's what we're going to practice with. So for each of the following, we're going to state the end behavior, which is whether it opens up or down, the vertex, and describe the shifts. Okay, so you can see out here it's positive, so it's concave up or opens up. This one's negative, so it's concave down. And this one's positive as well, so it's concave up. Now your vertex comes from in here, so it's a +8, +5. Remember, +8, +5. Remember, you change this sign, keep this sign. The transformation, the -8 is your horizontal shift. It's backwards, so you went to the right 8, and then you went up 5. On this one, your vertex is +3, -10. That means you went, and think about it like this. The original vertex is 0, 0. If you know what your vertex is, based on this, or looking at the calculator, you can always find in the table, to get from 0 to 8, you go to the right 8. To get from 0 to 5, you go up 5. All right, for this one, we went to the right 3 and then down 10. All right. This one's a little more complicated. There's nothing in the parentheses with x. So what number would that be? X plus 0. So your vertex would be 0, 2. And again, if you're not sure, there is no point in guessing when you have this graphing calculator. I'm going to clear these out. It's just x squared plus 2. Look at the graph. Oh, let's zoom. 6 is standard. The vertex is still in the center, it's just up 2. So that's the only transformation that it made. All right, so always compare it to 0, 0. All right, so I'm going to end the video there. For the practice, you're doing these same things. You're going to try and identify what this is. You're going to talk about the different shifts, and we're going to keep practicing with it. So if you have questions, stop by the math lab or stop and see me, send me an email, whatever you need to do. I'm happy to help. Have a good day.